MS Ramaiah University of Applied Sciences.
Hello students. In this video, we will be initially discussing the theory on hardness and subsequently dealing with Rockwell hardness test experiment. Hardness implies resistance to plastic deformation caused usually by penetration or abrasion. Hardness is not an intrinsic property of any material like density or melting point. It is rather derived from the composition of the specimen involved. Hardness test does not give any direct measurement of any performance properties. The test results correlates directly with its strength, wear resistance and other properties. Compared to other material testing types, hardness testing is inexpensive and non-destructive, easy to implement with properly calibrated equipment. Operators can be easily trained and supervised. Provides an accurate, rapid and economical way of determining the resistance of materials to deformation. Hardness is determined by measuring the permanent depth of the indentation. It means that when using a fixed force, load and a given indenter, the smaller the indentation, the harder the material. Hardness implies different meaning to different people. For example, to the metals industry, it may be thought of as resistance to permanent deformation. To the metallurgist, it means resistance to penetration. To the lubrication engineer, it means resistance to wear. To the design engineer, it is a measure of flow stress. To the mineralogist, it means resistance to scratching. To the machinist, it means resistance to machining. The application of hardness is varied and many. For example, it can be done for quality control for metal heat treatment, incoming material inspection, weld evaluations in steels and other alloys, grade verification for hard plastics, failure analysis. There are different types of tests for hardness measurement, namely scratch hardness test. The principle in this test is that an object made of harder material will scratch an object made of softer material. Indentation hardness. In this test, a constant compression load is applied locally on the material with the help of a sharp object like diamond or ball. Rebound hardness test, in which a diamond-tipped hammer is dropped from a fixed height onto a material and the rebound height is observed. Shore hardness test is a measure of hardness for polymers, elastomers and rubbers. Knoop hardness test is done for very brittle materials or thin sheets where only a small indentation may be made for testing purposes. Scratch hardness is a measure of how much resistant a sample is to fracture or permanent plastic deformation due to friction from a sharp object. The most common test is Mohs scale test. It is mostly used in mineralogy and the tool used for measurement is known as scalerometer. Observe that scratch hardness of some of the minerals including talc, gypsum, diamond, etc. are shown in their increasing order of hardness. Rebound hardness measures the height of the bounce of a diamond-tipped hammer dropped from a fixed height onto a material. This type of hardness is related to elasticity of the material. Hardness value is derived from the energy loss of a defined impact body after impacting on a metal sample. The device used to take this measurement is known as scleroscope. Indentation hardness test is primarily used in engineering and metallurgical fields. It works on the principle of measuring the critical dimensions of an indentation left by a specifically dimensioned and loaded indenter. Indentation tests normally used in engineering and metallurgical application fields are Rockwell, Brinell, and Vickers. Hardness measurement can be defined as macro, micro, or nanoscale according to the forces applied and displacements obtained. Macro hardness test is widely used for quality control and surface treatment processes. It is applied for bulk materials for obtaining mechanical property data. Examples of macro hardness testing are Rockwell, Brinell, and Shore hardness. Micro hardness test is applied for materials having fine microstructure and for those materials having multiphases, for non-homogeneous materials and materials which are prone to cracking. Examples of micro hardness tests are Vickers and Knoop hardness. Nano hardness test. In this test, hardness is measured by using a very small load of the order of 1 nanonewton. This test is used for testing very thin materials and coating, semiconductor wafers, biological specimens, etc. Example of nano hardness test is scratch test. The hardness of a material is inversely proportional to the grain size of the material. Hardness of the metal alloys is greater than the hardness of their individual components because the bonding forces between molecules that differ from each other are larger than those between the molecules that are similar to each other. In plastics, higher degree of polymerization increases the hardness of the material. Increase in percentage of carbon in steel increases its hardness. Hardness is expressed by the mean contact pressure, and the mean contact pressure is proportional to the yield strength. Hardness testing is a method of determining the results of heat treatment as well as the state of a metal prior to heat treatment. While hardness is a characteristic of a solid material expressing its resistance to permanent deformation, toughness is the maximum amount of energy a material can absorb before fracture. The elastic and plastic deformations allow materials to absorb large amounts of energy. Therefore, toughness of the material increases with decrease in hardness. Toughness tends to be small for brittle materials. Toughness is the area under the stress-strain curve and is a parameter that comprises of both strength and ductility. As indicated in the graph, for high carbon steel, the toughness is low while the material has high hardness. Similarly, for a low carbon steel, the hardness will be lower while the material has high toughness. Here is an illustration of the indentations obtained from the hardness tests. The specimens show the indentations made using Rockwell, Brinell, and Vickers hardness test procedures. Note that in the first specimen, 5 indentations have been shown. While Rockwell test has 2 pairs indentations 2 to 5, the smaller indentations 3 and 5 are for minor load and the bigger indentations 2 and 4 are for major load. The Brinell test has a single indentation 1. The 2 pairs of Rockwell test indentations correspond to B scale and C scale. In actual practice, the indentation due to application of minor load are superimposed by the application of major load. In the case of Brinell hardness test, the diameter of the indentation is measured and used for finding the hardness number. However, in Rockwell testing, the hardness number is obtained directly without measuring the dimensions of indentation. In Vickers hardness test, a pyramidal indentation 6 is formed as shown in the second specimen. Both the diagonals of indentation are measured and the average value of the diagonals is used for finding the hardness number. Now, we shall discuss about Rockwell hardness test. This hardness test uses a direct reading instrument based on the principle of differential depth measurement. The standards related to Rockwell hardness are ISO 65081 for metallic materials, ISO 20392 for plastics, and ASTM E18 for metallic materials, ASTM D78508 for plastics and electrical insulating materials. The result is a dimensionless number noted as follows: HRA, HRB, HRC and others, where the last letter is the respective Rockwell scale. The main parts of Rockwell hardness testing machine are machine body having loads and levers inside, elevating handle, elevating screw rod with sleeve, work table for specimen, main shaft with indenter, indication dial gauge, load selector, handle for loading and unloading of weights, Rockwell hardness standard scale. Static hardness testing methods are practiced at MSRUAS. The determination of the Rockwell hardness of a material involves the application of a minor load followed by a major load. The scale, the indenter, and the total load to be applied is obtained as per standard scale based on the material of the test piece. The type of indenter and the test load determine the hardness scale A, B, C, etc. The load is applied through an indenter. The indenter is located firmly in the main shaft with the help of an Allen key. The indenter may be either a right circular cone with a rounded diamond tip, 120° included angle, or a sphere made of hard steel, 1 by 16 inches steel ball or 1.588 mm. For example, for aluminium, copper and unhardened steel, a steel ball of size 1 by 16 inches or 1.588 mm indenter is used. Similarly, for harder material such as cast iron, pyrolytic malleable iron, steel, etc., the diamond cone indenter of included angle 120° is used. The cleaned test specimen is gently kept on the work table and is gently brought in contact with the indenter. First, the indenter penetrates into the test piece under the preliminary test force known as the minor load, 10 kgs, to a depth of penetration that is defined as the reference plane for future measurements. Automatically or manually, the penetration measuring instrument dial gauge is adjusted for 0. The minor load establishes the 0 position. The major load of 140 kgs is now applied. After 15 seconds time of application of the additional test force defined in the standard, the maximum depth of presentation is reached. At this point, the major load is withdrawn. The dial shows a reading that indicates the final hardness number. The reading on the dial gauge is now noted for the hardness number. The elastic fraction of the depth of penetration moves backward and the indentation persists at the remaining depth of penetration. While the major load is being applied, the dial indicates the depth of penetration from the 0 datum. A harder material gives a higher number. Hardness is measured directly from a dial, which is a measure of the depth of penetration, is inversely proportional to the hardness of the material. The standard way to write Rockwell hardness number is shown as XX HR scale / minor load / major load / indenter / dwell time. Example: 50 HRB /10/140/120 diamond cone /15 seconds.
Dear students, the name of the experiment is Rockwell hardness testing, and the aim of the experiment will be to find the Rockwell hardness number of a given specimen. The various apparatus used for Rockwell hardness testing is the Rockwell hardness testing machine consists of the main body which has the weights inside it, the elevating handle for moving the workpiece up and down, the sleeve on which the working table is available. On the working table we keep the specimen. The machine consists of the main shaft to which the indenter is fixed by the help of the Allen key. Next is the dial gauge. The dial gauge consists of an outer scale and an inner scale. The outer scale is the black C scale and the inner scale is the red B scale. In addition to the scales, there are two indicators here, one small and one big. For applying the minor load, both the indicators are used, and for the major load, the bigger indicator is used. Now on the right side of the machine, we have a standard scale. Please observe that this is the standard scale provided on this machine for Rockwell hardness. The scale has from A to V, indenter, load, dial, which is chosen for a particular material. In this machine, we have two scales, B and C. B is used for aluminum alloys and non-ferrous materials. C is used for steel and other hardened materials. Now, on the other side of the machine, we have the load selector and the levers. We will see that now. This is the load selector. Depending on the type of material for which the hardness is to be found, we can select loads. In this machine, there are loads which we can select from 100, 150 and 187.5 kgs. Now we will move to the load selector. This lever helps us to apply load and remove the load. When we turn the lever to this side, we apply the load, and then when we take it back, we remove the applied load. The indenter. For the steel sample, we need to use a diamond indenter. This is the diamond indenter. The Allen key. For fixing the diamond indenter to the main shaft of the machine, we need to use the Allen key and the specimen. For this experiment, we will be using the steel sample. For conducting the experiment, we need to first fix the diamond indenter to the main shaft. The diamond indenter is inserted into the slot provided in the main shaft and tightened. After fixing the diamond indenter, the workpiece has to be kept on the working table. The scale indicates that for a steel specimen which we have chosen, we need to use the C scale, the diamond indenter, 150 kg load and the black gauge. The selection of the load is on the other side of the machine. The load to be selected for steel specimen is 150 kgs. Now we will conduct the experiment. For conducting the experiment, we need to initially apply a minor load followed by major load. Now we shall first apply the minor load by rotating the handle and bringing the specimen in contact with the indenter. For applying the minor load, continue rotating the hand wheel until the indicators in the dial gauge meet a point, that is, the smaller indicator indicates 3 and the larger indicator coincides with 0. Note that the smaller indicator has coincided with 3 and the larger indicator has coincided with 0 of the black C scale. Now we need to apply the major load with the help of the lever on the other side of the machine. Now I am applying the major load. When I apply the major load, please observe the dial. The indicator in the dial keeps moving. and stops at a particular point. At this point, we have to allow 15 seconds as dwell time. This dwell time is provided for the elastic recovery of the material. After 15 seconds, we need to remove the applied load. Now, after 15 seconds, I am removing the applied load. While I am removing the applied load, please observe the dial gauge. It has settled, the indicator has settled at a particular point. This is the Rockwell hardness number of the considered specimen. To get the final hardness number, I have to repeat the experiment 2 more times at various places in the workpiece and then take the average of all the 3 readings. This completes the experiment.
At MSR UAS, we spark your imagination unlike any other.